Good morning. Thank you very much for coming. My name is Wielenga. I'm a product manager working at Oracle. Before that, I worked at Sun Microsystems for many years. And in this session, I want to talk about the topic of the enterprise and of JavaScript. And I must tell you immediately, I'm not a fan of JavaScript. I don't like the JavaScript language, and I don't like the JavaScript ecosystem. But we are in a world where we have to deal with the fact that JavaScript is there. And in this session, I want to talk really about how to deal with the fact of JavaScript, the fact that it is there, why it is so popular briefly, and how to deal with that reality. Basically, I want to give some tips and tricks as well. At some point, I'm going to go through 10 building blocks of a sensible approach to JavaScript. Now, of course, why JavaScript is so popular is because of the browser. So the browser is a platform that has won. I'm not sure what it was competing against, but it's won. You know, on all the devices that you can imagine, you have the browser. So you have the browser on your mobile phone. You have the browser on the tablet. You have the browser on your desktop, on your laptop. Anywhere you can think of, you have the browser. And it just is the way it is that JavaScript is the native language of the browser. And of course, currently everyone that's doing software development and organizations and users and so on, everyone wants to access their application from their mobile device because the mobile device has exploded massively. So everyone wants their applications on their mobile device, and of course you could, as a software development organization, spend time creating an iOS app and an Android app, but then you need an iOS team and an Android team, or you need people who have skills in both, and you have to maintain two separate code bases. So what the enterprise in general is doing is, on the front end anyway, using JavaScript for their user interface. What happens on the back end is, it varies. Some people are doing Java, some people are doing, JavaScript with Node. There's all kinds of things happening on the back end, but it seems very clear that if you are, welcome, come in. If you are if you are creating enterprise-type applications, so by that I mean kind of applications like in the finance area, in logistics, kind of the applications used in organizations like Tesco, for example. This is a time scheduling application created in JavaScript on the mobile phone of the employees of Tesco, and they can schedule their time and they can say when they are there or not. And what Tesco wants to do is they want to make a marketplace available so that if you can't make your shift, that you can say, I'm putting my shift on the marketplace, and then my colleagues can bid for that shift, or the manager can put shifts onto your marketplace. So there's all these marketplace ideas, all these service-oriented approaches, everything as a service, and the cheapest, simplest, most effective way to get a user interface on top of everything else is to use JavaScript. So that's the world in which we live. So there are all kinds of projects that have arisen, and one that I found really interesting is Kraken.js. I was at a conference, and the VP from PayPal was doing the keynote, and I thought, what does the VP of PayPal have to say to developers? And it turns out that PayPal has an open source division, and inside of PayPal, they have developed a framework on top of Node and Express, which is called Kraken, which they've been using for several years, and they've open sourced it. And so now the VP of PayPal can go to developer conferences and talk about PayPal as a cool place to work, because all these organizations, of course, are competing for developers. There's an immense demand for new developers, new testers, new this, new that, and the whole IT is exploding, really. I mean, it has for years. You can find jobs everywhere. So PayPal, via this Kraken framework, is able to go to conferences and do keynotes and say, come and work for us, we're using JavaScript. In the same way, Tesco can do that too. They can go to conference and say, hey, come and work for us. We are using open source tools and technologies, we're using JavaScript. So all this is going on, and as a developer who is a bit skeptical about JavaScript, you look at this development and you wonder, How long can this last? JavaScript is problematic on the language level because of a missing type system, and then you have TypeScript that you can use. Okay, so then you think you've solved that problem. Then the JavaScript ecosystem itself is, of course, very volatile, very unstable. People who like JavaScript would say it's innovative. That's great that it's innovative, but every week there are new libraries. Every week there are new libraries to learn, which is great, and then you learn your new library, and then the week after those libraries are gone. It's not a very stable ecosystem to create enterprise applications. In the enterprise, you want to have an application architecture that is stable. You don't want an architecture where every week you have to create some new code for a new library that you need to hook in. Especially from my Java background, what I like about Java is it's stable, and I appreciate it much more now that I'm involved in the JavaScript ecosystem, because in the Java world, I used to think, well, everything is slow. It takes a long time before there are new features. But now I think that's great. It's stable. You can really create meaningful, stable applications in that ecosystem. Can you do the same in the JavaScript ecosystem? Clearly, organizations are doing that. Tesco is doing that. PayPal is doing that. At Oracle, that's happening. IBM, Microsoft, all the large organizations are doing that. What is going on under the hood? What kinds of applications are being created? Are these applications hacked together? What kinds of libraries are being used? Do these applications have to be rewritten every few years? These questions are worth asking. So I've mentioned PayPal at 10:15, so right after this session, and in the room furthest away from this one, in this building, on the ground floor, I'm doing a talk about what Oracle is doing with JavaScript. So I won't talk about that in detail here, but I'll talk about the whole Oracle strategy around this. And Tesco is one of Oracle's customers, and they're using Oracle solutions for front-end JavaScript. So if you want to find out more about that, everything I will talk about is free and open source. So Oracle has lots of free and open source technologies and libraries and things that you can use that are used inside Oracle. So come to that session, and I'll talk about that. So to give another perspective on the situation, this is a photo that went viral on Twitter a few years ago. I'm from Amsterdam. This is probably the most famous Dutch painting ever, Rembrandt's Night Watch in the main museum in Amsterdam. And you can see a bunch of kids in front with their backs turned to this great work of art focused on their mobile devices. And this caused a major uproar in the Netherlands. This was clearly the end of the world. This was clearly the end of the world. Future generations focused on Facebook with their backs turned to the great art. Something had to be done, something had to be done to solve this terrible situation. But actually, and in the meantime, we probably are familiar with this development, they were not actually distracted at all. They were using the museum app. They were researching, they were reading up on the painting that they had just been looking at. And in the picture next to that, you see what they were doing seconds before that picture was taken. The same people sitting on the floor engaged. This whole mobile development is not a question of people being distracted or being removed from reality. It's a way for people to be engaged in reality. It's a much more positive thing than we thought or feared, or older people thought or feared maybe 5 years ago. Nowadays, we're much more aware of this. I was in a cab on the way to the airport in the Netherlands, and the cab driver asked me, "So what flights are you on?" And I said, I gave him a number, I wasn't sure why, and he punched it into his phone on his dashboard, and he had the airport app installed, and he could see whether I had a delay or not. And I said, "Hey, that's great. What app is that?" And he gave me the name, and I was sitting in the back seat, and I searched for that app, I installed it. 2 seconds later, I was using that same app, and it's amazing what technology now makes possible, that there's such a quick transfer of information, of apps, and all these possibilities. And JavaScript can play a meaningful role there. But the question is how to deal with the problems of the JavaScript ecosystem, and how to manage the constant changing environment there. So I must say I am not a a JavaScript promoter. I'm really come from a strongly Java background. I think JavaScript has a role to play on the front end. I'm even more skeptical about JavaScript on the back end. I'm even more skeptical about Node than I am about JavaScript on the front end. I would say Java is great in these contexts. And I want to talk about the browser platform on the front end. What goes on the back end, I'm leaving out of this story. This is really a front-end JavaScript story. And this is the problem, of course. And at the same time, this is the wonderful thing. We have so many choices in the JavaScript ecosystem. We have so many different choices. And it's very hard to know if the choices you make are right. And what does it mean? What is the right choice to make? And how do you evaluate these different frameworks? How do you evaluate the different libraries? How can you have a meaningful choice when there are just so many of them and they come and go all the time? That's really what I want to. Talk about a bit. So these are the 10 building blocks. I'm not going to keep it a secret and build up. I'll tell you from the very beginning. These are the topics I want to talk about. I think, this is an approach to different insights into dealing with the volatility of the JavaScript ecosystem. So first, I'm going to talk about resisting the hype. Then I'm going to, even before talking about JavaScript, I want to talk about HTML5, because a lot has gone on there. That is really interesting. I see HTML5 much more as an application framework than it used to be. We're going to look at CSS as well, and CSS is also different to what you might think. The benefits of CSS are different. I'm sure you're going to learn some interesting JavaScript alternatives there. Then the big topic of framework versus library. We're going to look at modularity, look at some abstractions, and then I'm going to tell you why you shouldn't worry about the volatility of the ecosystem, introduce you to something different to write once, run anywhere. That's really the Java story. I'm going to introduce you to something different called Wanta, and I'll tell you what that is later. We'll look at some corporate frameworks, what corporations are doing, and maybe finally we could also look at JavaScript as an assembly language rather than a programming language, and I will talk about that too. So hopefully we can fit everything in. The first thing, very first tip to a sensible approach to JavaScript is to resist the hype. Resist the hype. Resist the whole technology stack. Resist the frameworks and the libraries that are new. Resist anything that is new. Play with it, but don't commit to it until you really need to do so. So I want to give you an example. Air traffic control systems. So I've been involved a lot with the Java desktop over many years. I think the Java desktop is wonderful. I think Java Swing is wonderful. And I still think so. And it's these desktop systems have a very specific use. You know, for example, air traffic control system, you have maybe 20 users of the system sitting in the same room. Why would they need a browser application? You know, a browser, a front end is useful if you want your application to be accessible across the world, across different people, different organizations. If everyone is sitting in the same room together, why would you need a browser front end? Also, of course, if you're creating an air traffic control system, no way do you want to create a mobile app to land planes. You simply need a very large resolution for these kinds of software systems. What might be useful in these contexts is to supplement that system. So instead of listening to your manager when the manager says, rewrite everything to the browser, what you should do is you should make the argument that you should keep the existing system and supplement it. So add a web app to that desktop system for reporting, so to display reports. Add a mobile app to that desktop system for notifications and so on. This really is what a lot of organizations are doing. They are taking the sensible approach of not throwing away their entire desktop system, whatever it is, but they are complementing it, they are supplementing it with other, with these modern devices, modern technologies, modern a mobile app, a web app, and so on. Leave things the way they are and supplement with these new technologies as much as possible. Because The browser doesn't fit everywhere. It's not a silver bullet. It's not the right place for every imaginable system. In science, in military defense force type applications, in air traffic control systems, in all kinds of very complicated environments, the browser isn't the appropriate choice. So the second perspective I'd like to offer you is that HTML5, before we even look at JavaScript, HTML5 is more than you might think. And when you hear about HTML5, typically what you think about is multimedia. You think about video and about audio and about all those different things because HTML is nowadays so much more than what it used to be. HTML originally was there as a markup language for scientific documents. P1, or H1, P tags, B, italics, simply for marking up scientific documents. In the meantime, people want to have full multimedia experiences. So there's this audio tag, and there's a media tag, and there's a this tag, all for multimedia type stuff. However, in addition to that, there is much more. There are components that are part of HTML5 that are very interesting for application development. So, for example, there is error validation for the first time, and I want to show you something as a quick example. So I'm just going to create a quick example to show you some interesting components in HTML5 that you might not have thought were there. And what I'm using is a tool that is becoming an Apache tool. So what you see here is Apache NetBeans Incubating, free open source tool that you can go to netbeans.apache.org and you will see information about this. Free open source, and you can become involved in this project too. So I'm going to just run this little HTML JavaScript application into the browser. I'll make this a bit bigger. Control up. So there we go. So you can see here to do write content. I'm just going to make this a bit smaller, put them next to each other since I don't have two screens. So I'll put this one right there. And I'll move this guy next to it so that we can see the action in the browser at the same time as development in the development environment. So there they are. Okay, and I'm just going to undock this and make this bigger. Right. Okay, so I'm just going to make a change here. Hello world, save it. Okay, let's delete this. You can see here there's this whole HTML5 category, and what I wanted to show you is code completion. Did you know you can create an IntelliSense code completion component using pure HTML? So you can see here that there is this input element. You can see an input element like you would normally have for text. In addition, though, there is this required attribute. So this is new in HTML5, so we have validation built into HTML5. Secondly, there is this attribute list. And the attribute list has this value country, and then there is a data list element, which is new, which is completely native HTML now, same as H1 and P. You have data list, which is connected to this input element by this ID. And now, in here, we have code completion. So I can start typing, and you can see that this automatic filtering is built in. Now, all the browsers support HTML5. So all the browsers support this native IntelliSense, which means you don't need to use jQuery for this. So if you've been using jQuery for these kinds of more complex components, you don't need to do that. You need to investigate what HTML5 provides itself natively. Another example is if you've been using calendar type components from jQuery, there's actually different kinds of calendar components natively in HTML. So this input type here, in this case, is set to date here. You see here date, and you can see time and week. So here's date. So here's a complete date picker. You don't actually need jQuery. And also you can see here that there's a step is set to 7. So we can only pick something on the Monday. So you can really set limitations within the calendar. In the second one, you can see that we have a time picker here. And in the last one, there is in this case, we can only pick certain days within this week calendar. So the point I'm making here is that HTML has much more natively than it's had before. And you should definitely take a look at the HTML5 specification and take a look at what is offered there now. So there are new features in HTML5, and the principles of HTML5 are that they should be based on HTML, CSS, and JavaScript, no plugins like Flash and so on. Error handling is built in, so there's required attribute, no scripting, and of course device independence, because we want to be on mobile ultimately. So I've shown you this example, connecting an input element to a data list for code completion, and I've shown you a demo. So now, something about CSS and JavaScript. So what we're talking about in this session are ways in which to approach the problem of JavaScript and what the JavaScript ecosystem offers. How to counteract the volatility of the JavaScript ecosystem with a sensible approach. And the first point I made was to resist the hype, to not follow all the new trends and things immediately, to be very careful what you select. The second point I made was that you should reassess HTML5, reassess the components that HTML5 provides, because it's not only about video and audio, it's also about application framework. Now, of course, CSS, everyone is aware that CSS is really focused on responsive design, CSS3 especially. So again, CSS originally was a style sheet language for describing scientific documents, just like HTML. But CSS3, what it has is big focus on is the concept of media queries. So you can say, if the screen size is like this, then show it like this, and if it's like that, then show it like that. And the other interesting thing is about CSS3, it's actually a modular specification. So CSS3 isn't actually complete. Only some parts of CSS3 are complete, and especially the media query part is complete, and is the one that everyone knows about. However, there is something that you maybe don't know about, and that is that what media queries do is they show and hide DOM elements. And what they don't do is they load and unload. That doesn't happen with CSS3. And I want to give you a small example to illustrate this point. CSS3 does less than what you think what you might be thinking it does. So let's close this little application, and we'll run another one. So we imagine in this scenario that we are creating an application for Coca-Cola. Okay, it doesn't look fantastic yet, of course. We're just in the beginning stages. But we have like this menu bar along the top here, and we have this logo up here. And you can see there's a text over here using a large resolution. However, we know that once our application is accessed from a mobile device, that this logo is going to take up too much space. So we have set up the application in such a way that when we are on a small resolution, that logo isn't shown. Now, if I was using CSS3 media queries for this, that logo would still be in the DOM, even though it's not shown. And that's not the effect that you want to have. Ideally, what you would like to have is that when the resolution is like this, that logo is removed from the DOM. Because imagine it's not a logo, imagine it's a map. So if we're on the resolution of a browser on the laptop, we want to use a map that we have built into the application. If we're on the resolution that's on the mobile device, we want to use the native map on the device. So we don't want to somehow secretly still have the loading of the map on the mobile device when we don't actually need it. What we want is we want that complete map to be removed from the DOM. And that's what JavaScript enables you to do. So the tip here is to look at two libraries. One is called response, and the other one is called foundation interchange. And so here I have response.js.com and foundation interchange, foundation.zurb.com. These are really useful libraries. And so let's take a look at the context that we're looking at here. So I'll make this small again, and we'll look in the development environment. I'm going to open a small window here which shows the live DOM. Okay, so in this window on the left, in the bottom, when I click on items in this window on the left, you can see that the related item in the browser is selected. So I have connected my development environment, NetBeans, to the browser via a plugin for Chrome. So in the Chrome App Store, you can find a NetBeans connector plugin. I've installed this into the browser, and now when I click on these items in that window, or the other way around, I can see where I am, which is of course very convenient. So, but the point is, let's click on this logo here. So I'm going to connect this to that. Click on that logo, and I'll click on here. You can see as I click on something different that this window in the bottom left changes and shows me new information. So I'll click on that logo. So there's the logo. You can see it, here it is, right? Now, I make this browser smaller to resemble a mobile device, and we will see the logo disappear in the browser, and you should take a look at what happens in this browser DOM window. You can see that entire div appears and disappears. This is because, if you take a look at what's going on there, here is the source code that is used here. So we have here a condition that is provided by means of knockout, a data bind. So if we are small, then show the logo. And here is a definition of we are small. I am using here response.js, which lets me set breakpoints. So here I have created breakpoints, 0, 4, 84, 81, and here we have response.action, and we can say here, if the breakpoint is between 0 and 480, then set our variable to true. And if it's not that, then set that variable to false. So we were able to set variables based on the resolution of the browser, which we can do thanks to response. And there's also this other handy thing. You can see this text. You are using a small resolution here. And as we get bigger, you will see that it says you're using a medium resolution. How is that done? That is done because in the application, we're not only making use of response. So in the first example, we're using response. In the second example, with these texts, we're using foundation interchange. And you can see, again, there's this concept of breakpoints, small, medium, and large. So if the breakpoint is at small, then load the small HTML file. Otherwise, if the breakpoint is medium, then load medium HTML. So my tip here is, in this case, is to, in the JavaScript ecosystem, really use JavaScript. Don't use CS3 media queries because they are hiding a problem from you. They're hiding the fact that media queries are not loading and unloading elements from the DOM. They're simply showing and hiding them. So explore response and foundation. Next, the big problem in this landscape, of course, is the massive proliferation of libraries and frameworks. How do you make the right choices? You know, and what is the right choice? 5 years ago, the right choice for a front-end JavaScript library apparently was Backbone. And then, after that, it was apparently Angular. And now people are crying because Angular 2 isn't really backward compatible with Angular 1, so people have to rewrite stuff. And so people are looking at React now. So now React is becoming very popular. And in 2 or 3 years' time, it will be something else again. So what is right depends, of course, on the context in which you are working. And this is what we need to look at. What is that context? How long do your applications need to exist? And these kinds of concerns we're going to examine. So the choices are many, of course, and here are just some of them. On the framework library side, you have Backbone and Ext and Angular and Ember and Knockout and Meteor and React, and everyone's talking about React right now. And you can look at module systems, Browserify and Require and System.js in Angular, and you can look at Prototype and all these other libraries on top of pure JavaScript. And there are the testing frameworks, and you can look at Ionic because you want to create your mobile app from Angular, and you can look at Bower because you want to do dependency management. Oh, but Bower isn't going anywhere, so now you have to look at Node, and then you look at Yeoman for scaffolding, and you look at Grunt, and you learn all about Grunt, and then everyone tells you have to use Gulp, and then you learn about Gulp, and then you learn that there's something called Brunch, and then you learn about Brunch, and all these things keep going on and on and on and on. So the first thing that you need to do, of course, is organize all these different libraries and frameworks into categories, And be very careful with doing these comparison searches on Google, these Google Trends. I found Google Trends very dubious, very unreliable, because you put in Angular and Knockout and Backbone and a few others, and you see Angular is like this, and everything else is like that. And what that means, I think, is not necessarily that Angular is being used everywhere, but Angular is being researched everywhere. Everyone is Googling for Angular. Doesn't necessarily mean that everyone is using Angular. You've got to be very careful with these statistics. Also, these job search results. The different ways, these different graphs and charts that you can very easily create. It's very difficult. Probably one of the best things to do is not to necessarily do what everyone else is doing, but to look at your own context and what is relevant in the specific scenario in which you are working. But in general, there are two approaches. In general, you can take the framework approach. And the common framework is Angular 2 or 3 or 4. Angular is the common framework that everyone is using in the JavaScript space. That is a popular approach. Angular gives you everything. You have an entire ecosystem. You have books. You have all kinds of things going on. However, what you do have with a framework as a downside is lock-in, and also a very closed ecosystem. In the framework, it's very difficult to introduce new libraries, because the framework has a very specific philosophy. So maybe a wiser approach in the context of a constantly changing ecosystem like JavaScript is to instead choose a few libraries that are relevant to you, that you have chosen yourself. And as the ecosystem changes, change those libraries. It's definitely a different approach, and it also, of course, has its own problems, because if you have 5 or 6 different libraries and you combine them together, you don't know for sure if they work together so well, and you have to figure it out yourself. You're basically creating your own framework, and when things go wrong, you can look for answers to questions about Knockout together with your 3 libraries, and then you find an answer which is relevant if you're using Knockout with 4 other libraries, and not the ones that you are using. So it can become quite fragile. But what you can also do is you can, for example, what is happening at Oracle is the library approach is taken. At Oracle, the approach is take a few libraries, bundle them together, package them together, distribute them together, and that is the Oracle Jet solution, which I'll be talking about at 10:15. So if you want to see how Oracle is solving this specific problem, I have a session on that topic. Another very important tip: if you are creating larger applications for the enterprise, incorporate modularity. So some way for the different parts of the application to communicate with each other in a more or less loosely coupled way, some way to structure our application. JavaScript wasn't created for this, of course. JavaScript wasn't created for large enterprise applications, so modularity isn't natively built in. Of course, in the latest ECMAScript 6, modularity is introduced for the first time, but for a long time it hasn't been there, and there have been different libraries that you can use for that purpose. So there's Require and Browserify, which are both quite popular, not the newest, but definitely stable. And I would say, don't choose the newest, don't go after the hype, but choose things that have been around for a while, that have a community, that have documentation, that are not being hyped. System.js is part of the Angular story, and ECMAScript 6 has its own module system. So a quick tip in between: you don't necessarily need to use JavaScript, CSS, and HTML directly. Instead, there are abstractions over it. So there's an abstraction over JavaScript, abstraction over CSS, abstraction over HTML. For JavaScript, I'm sure most people in this space have heard about TypeScript and CoffeeScript. With CSS, you don't have to use CSS directly. You can use Sass, super awesome style sheet language, which is what I like about Sass also is that they've introduced a complement into their name. So if you ever think of a name for your technology, include super awesome in it, because immediately people get a really nice impression. Sass, super awesome style sheets, less as well. So these are post-compilers, pre-compilers for CSS. Emmet, maybe not everyone has heard of this. It's a really nice little tool. It's integrated into most IDEs and editors. Emmet.io. The simplest way to understand this is, I'm sure they have a little example here. They have nice little syntax here. So, for example, you would type this in your editor, div and a forward arrow and UL and a forward arrow and li, and then you press enter, and then this is generated from that. So it's a very simplified HTML language where from that first abbreviation you can generate the full HTML code. So you can very quickly type your markup, press enter, and all of that is generated for you. So that's Emmet is definitely something to look into. So Emmet, TypeScript, CoffeeScript, Sass, and less. Okay, so here's the thing. Here's the main point. Don't worry about the volatility of this ecosystem, except if you are really worried about it, maybe this isn't the right place for your software. That's completely possible. So basically, the way you should see it is the lifespan of your app should equal the lifespan of the framework or the current release of the framework that you're using. More or less 1.5 years to 2 years. If you are able to, or if you are willing, or if it's part of your natural flow to rewrite your application every 2 years or so, the JavaScript ecosystem is perfect for you. If, however, you are creating air traffic control systems, large scientific software, these heavy systems that need to do heavy data processing, heavy visualizations that have hundreds of developers working on it, that need to exist for the next 20 years or so, more or less in a stable fashion, probably this is not the right place for your system. However, if you think of it in this way, that the software that you're writing needs to exist for, needs to be aimed to be rewritten every 1.5 to 2 years, more or less, that has consequences. If you're aware, if you as a developer are aware that your system doesn't need to be there in 5 years, how worried are you about the readability of your code? How important is maintainability of code? So this is when I look at a lot of the enterprise applications that I'm seeing being written, I worry about what is going on on the source code level. How maintainable are those applications? Maybe it doesn't matter, but a lot of this stuff that's being hacked together because it doesn't have to be maintained forever could have an impact on performance of really important systems that are being written nowadays. I mean, I know JavaScript is browser-oriented applications are used in like Tesco and Oracle and IBM, but also like police force, immigration systems, education, taxation systems. What happens if we use JavaScript really too much, more than for what it was intended, and we really reach those limits. And of course, the problem is as well that people create a small prototype in JavaScript, for example, and then that prototype is used as the basis of the real software. What very rarely happens is that you make a prototype, and then what you should do is delete the prototype and start from scratch. But no one does that. You write a prototype and you think, nice prototype. I'll use this as the basis of my entire enterprise system. And we might end up in situations where software systems become really problematic, and we as an industry might end up in a situation where we have a pretty bad reputation and so on. So these kinds of situations could arise. But if your system is really applicable to the browser, if what you are doing is relevant and can be expressed in JavaScript, and you're okay rewriting your application every year or two, then this is the right place. There's no reason to be worried. It all makes sense. What that means is that from my Java background with write once, run anywhere, we are kind of in a new space, which is symbolized by this and expressed as follows: write once, never touch again. So if you can find yourself in that, if you are writing mobile apps, writing a mobile app, publishing it to the App Store, writing the next mobile app, publishing it to the App Store, when there's a new feature request, it's 6 months later, there are 3 new libraries. You start your application from scratch. So it's really this completely different development mode to the more traditional ones. And this may become the new approach. Write once, never touch again. If it makes sense for a particular context, it then obviously is the right approach to take. Now, what is really interesting in the JavaScript ecosystem is what the enterprises are doing. And I've already mentioned PayPal and I've mentioned Oracle, but I want to mention a couple of other ones. Because this wasn't the case 3 years ago, 4 years ago. Large enterprises were not active in the JavaScript ecosystem. But Microsoft, IBM, Salesforce, SAP, ING, very interesting. ING is my bank, so it's just I see the website all the time. They have this very specific colors and components and everything. They have a framework called Spectingular, and it's based on Angular, and you can see ING is in there, and spect from spectacular, so Spectingular. And it's on GitHub. So if you want to create applications using the components and the styles and so on of ING, you can do that. I've mentioned Kraken. I've mentioned Oracle, and in case of Oracle, it's Oracle Jet. So this is really a sign that one should be able to rely on this ecosystem because large enterprises are doing the same thing, which wasn't true a couple of years ago. Large enterprises are investing a lot of developer time and framework development and library development in this JavaScript ecosystem. And why? Well, same as everyone else, cloud. So I mentioned from the start of this session that the browsers on all the devices, and everyone wants to have their apps on mobile devices and so on. Mobiles are everywhere. But from the point of view of these organizations, they're all positioning themselves as cloud companies. And so they have data in the cloud, and they have services, and all kinds of services, and APIs, and REST endpoints, and so on. And so then you have your data in the cloud, but you want to do more than that. You want to visualize that data. At some point, you want to do something with the data. You don't only want to store data on someone else's server with scalability and all these different features that the cloud provides. You also want to visualize that. So these organizations are creating solutions. They're creating data visualization components, graphs and charts and all kinds of things. And in response to these kinds of enterprise requirements, these are typical enterprise needs. Responsive design. The application should change its shape based on the resolution of the screen. Modularity. Application should be broken up into smaller pieces. Single-page application architecture. Really important, especially for mobile devices. A whole new philosophy of how to structure an application. Accessibility. There are all kinds of rules and regulations in the US especially about that an application must be accessible by screen readers and other external devices for people with disabilities. So how do you create an application that supports that? Internationalization. That's not something that you care about if you're creating a small game or something, but if you're in the enterprise, if you're creating applications in IBM or Microsoft or these large organizations, this is a very big concern. Security, of course. Standards, try and follow those standards where there are documentation, support. These are enterprise concerns. And so in the case of Oracle, there's this Oracle Jet solution. PayPal has Kraken. ING has Spectingular. And everyone is trying to resolve these different concerns in different ways. And so in the case of Oracle, there's a whole bunch of free and open source graphs and charts that you can use. These are created on jQuery UI. These are standard jQuery UI widgets. You can integrate them into your own Angular application or into your whatever application you like, or you can use the architecture that Oracle Jet provides. So there's a very specific way of structuring applications using JavaScript in Oracle. So these are the kinds of applications being created. So these are applications in Oracle. You can see that they're very visually orientated, so very dashboard-like. This is typically what you see in modern applications in the enterprise, very visually, graphically appealing. That's what's happening in the enterprise on the front end. Very attractive, very dashboard applications where you immediately get a quick impression of what's going on underneath that system. But in the case of the Oracle solutions, I'll talk about that in my next session downstairs in Cupertino at 10:15. The final point I want to make is you don't have to use JavaScript as a programmer, even though the browser requires JavaScript. So JavaScript as assembly language. So you might think, what does JavaScript have to do with assembly language? This is assembly language, right? So what's the big deal? So where does JavaScript fit in? Well, this is JavaScript. Looks a lot like assembly language to me. Okay, it's minified and all kinds of things, but this is JavaScript. I would not want to code this. I don't know if anyone would want to code this. JavaScript is the language that the browser requires. And if there is a system that requires a very specific language, then that language is assembly language for that system. And so the argument can be made that JavaScript is assembly language. Now, there's a very interesting site you can go to. Let's see, so github.com. It's something like this. Josh Kenna's CoffeeScript. So you can Google for this, list of languages that compile to JavaScript. And it's a very, 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 very long list. Every programming language has some way of compiling, Python, Ruby, Erlang, Perl, Java, Scala. And it's clear because all these different languages, you want what you code to be available to the browser. In the case of Java, so that's my background. So there are a number of solutions here. So Vaadin is a Java library on top of Google Web Toolkit and especially focused on UI components, graphs and charts. And what's nice about Vaadin is that it has a component model comparable to Swing. So if you've done Java Swing programming, you will really like Vaadin because it has a similar component model, a tree structure of structuring applications. Another one is called Gluon. And what is great about Gluon is you can write your application in Java, and from that Java application you can generate a mobile application or an application for the desktop using JavaFX or for the browser. So Gluon is an interesting one to look at. Codename1 is similar. Codename1.com, create mobile apps from Java. And JavaScript. JavaScript is also a very good choice. So I would recommend, if you want to remain in a Java programming world in the context of the browser, to take a look at these 4 specific solutions and to compare them with each other. What I like about JavaScript, I really like the JavaScript solution because you get a set of Maven archetypes. So you can type Maven, blah, 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 JavaScript. It sets up your project for you. And from one code base, so you code once, and from that code base, you can generate an Android APK file, an iOS file, a desktop application via JavaFX, and a web application, because JavaScript has its own transpiler to JavaScript. The interesting thing is that every single device, in addition to having a browser, also has Java. So there's Hotspot on the desktop. There's Delvik on Android. There's something on iOS. And there's this back-to-browser solution on the web for converting from Java to JavaScript. And each device also has some kind of web view. So the desktop has a web view via JavaFX. Android has a web view. iOS has a web view. And of course, we have the browser. So what JavaScript does is it combines these different solutions into one package, so that from one code base you can generate applications for all those different endpoints. So that's really what JavaScript focuses on. So to kind of wrap up the story a bit, my advice to anyone investigating JavaScript in the enterprise is to be very careful and to not follow the hype and to resist it as much as possible, and to, first of all, to make the argument, we have an existing system, it's working fine, our users are happy with it, and on the development side, things are going well. The only people asking for this to be in the browser are the managers of the developers and the managers of the users. It's normally the users of the system are fine with the way it is. It's always it's kind of management-driven development. The manager's saying, we need this to be in the browser is the new thing, we need to be in the browser right now, let's rewrite everything to JavaScript. I would suggest keep everything the way it is, but add a mobile app for notifications and a web app for reports, and supplement the existing system with these new things. The second point is to look at HTML5 in a whole new way. It's an application framework. You don't need jQuery for many things. You don't need it for date pickers, for time pickers, for code completion components. There are real components, aside from the multimedia components built into HTML5 now, that you can use natively. Also, if you are using CSS media queries, make sure that you are using them and getting from them what you're assuming, because CSS media queries don't load and unload DOM elements. They show and hide them, and you may prefer the JavaScript approach via response and foundation interchange. The biggest problem is choosing the right frameworks, the right libraries. You really need to be careful. Right now, the hype is React. What it will be in 3 years is anyone's guess. So that has consequences for how you structure your application. The architecture of your application is very important. You need an architecture where you can anticipate change. That's for sure. You need to be aware that in 3 years' time things will be different. So you need to evaluate how you can decouple the pieces of your application. The architecture of enterprise JavaScript applications is really important because you don't want to rewrite everything every few years in the enterprise, definitely. Look at solutions for modularity. Look at these. Look at TypeScript, CoffeeScript, Sass, Less, and Emmet. Evaluate whether this is the right place for your system. Think about write once, never touch again. Does that apply to your system? Can you interact with your system in that way? Write once and never touch again. When do you need to touch your system again? How much change will there have been in the meantime? The most interesting development on the enterprise in the last years in this space is definitely that Microsoft, IBM, Oracle, all these organizations, Salesforce, all have JavaScript-based solutions. Some have proprietary solutions, some have open source solutions, but all these organizations are involved because JavaScript is in the browser, because JavaScript is a popular language, because people coming from universities and colleges have JavaScript knowledge, so can start working on projects immediately. And the final point is to maybe look at JavaScript as an assembly language, and not necessarily something that you need to write in. You should explore the transpilers that are available if you really can't handle the language that is JavaScript. That's it. That's my advice. And thank you very much for attending this session.